We will discuss in detail about the spherical mirrors now. We have seen with the simple example of a spoon, when we see it from the convex side or concave side, we notice that with the position of the object, size of the image, position of the image, as well as the orientation of the image changes. To find out how these things are related with the position of the object, we will use the ray diagrams. To draw the ray diagrams, we presume that the object is finite size and it is placed in front of the spherical mirror. We will consider only few rays which are emerging from the object and hitting the spherical surface to draw the ray diagram. But actually the whole object is emitting infinite number of light rays which are hitting the spherical surface and forming the rays. But for the convenience, we will just take 2 points of the image and we'll draw the ray diagram, and the others ray will follow the same pattern and the image will be formed. First case we will see when object is at infinity. In that case, the light rays falling on the mirror will be parallel to the principal axis. We have discussed this earlier also. All the rays which are falling parallel on the mirror, after reflection, they will go through the focus of the spherical mirror. In the case of concave mirror, all the rays which are falling parallel will be converging at the principal focus. Now we'll try to understand why. Here we know, if we talk about the ray which is the upper one, if we say ray 1, which is coming from infinity parallel to the principal axis, is hitting the point of incident here is D. Now we know that the rays will follow the law of reflection everywhere. So angle of incident has to be equal to angle of refraction. To find out the normal, simply because it's a part of big circle, so this is the tangent to that point. We drew a tangent to that point, and if we draw a normal from that point, we notice that this point will always go through C, the center of curvature. From here on, we will take the line joining center of curvature, and any point of the mirror is normal to that point. So in this case, it will be reflected. Angle I will be angle to R, and it will pass through the focus. Now we take the second ray, which is falling on the pole of the mirror. According to the same principle, it will retrace itself back. It will follow its path backward and pass through the principal focus. Simply because angle of incident for this is 0, so also angle of reflection for this ray 2 will be 0, and it will pass through the focus, retracing itself back. In the case of convex mirror, the rays will follow the same principle, and that is angle of incident is equal to angle of reflection. Now see the case when object is at infinity, angle of I is equal to angle of R. The rays parallel to the principal axis when the object is kept at infinity. With the same concept, we will see the convex mirror will behave in this scenario. So again, ray 1 and ray 2 we consider, which are parallel. So ray 1 is falling at a point of incident somewhere at D. The line joining that point with the center of the curvature is normal to that point. In the case of convex mirror, it is a diverging mirror. So the light will be reflected back and will be kind of spread out with the same angle. If it is, this is the angle I and this is the angle R. So angle, the ray 1 is making angle I with the normal, and the reflected ray is making R with the normal. Both of them are same. But in the case of convex mirror, the rays will not meet anywhere because they are diverging from each other. But for the observer is here, then it will look like as if it is emerging from another point. So if we extend this ray, it will look like it is emerging from the principal focus. So in this case, it is on the other side of the mirror. Similarly, for the ray 2, we will know that it will retrace back and it will also seems like emerging from passing through the principal focus here.